Bohr's model of hydrogen atom. Bohr combined classical and early quantum concepts and gave his theory in the form of three postulates. These are: first postulate, an electron in an atom could revolve in certain stable orbits without the emission of radiant energy, contrary to the predictions of electromagnetic theory. Diagram shows that orbit as stationary state of the atom. Each atom has certain definite stable state in which it can exist, called the stationary states of the atom. Second postulate. This postulate states that the electron revolves around the nucleus only in those orbits for which the angular momentum is some integral multiple of h by 2 pi, where h is the Planck's constant, equals to 6.6 multiplied by 10 minus 34 joules, or L equals to nh upon 2 pi. L is quantized. Third postulate. It states that an electron might make a transition from one of its specified non-radiating orbits to another of lower energy. When it does so, a photon is emitted having energy equal to the energy difference between the initial and final states. The frequency of the emitted photon is then given by hnu equals to EI minus EF, where EI and EF are the energies of the initial and final states, and EI is greater than EF. From the Bohr postulates, we can write Ln equals to mvn Rn equals to nh by 2 pi. Angular momentum is an integral multiple of h by 2 pi. We get Rn equals to n by 2m into h by 2 pi square into 4 pi epsilon naught by e square. Let us call this equation 1, and velocity Vn equals to 1 by n into e square by 4 pi epsilon naught into 2 pi by h. We call this equation 2. Now if we put n equals to 1 in equation 1, we get r equals to h square into epsilon naught by m into e square, which is known as Bohr's radius. It is also represented by a naught. The total energy of the electron in a stationary state of the hydrogen atom is given by En equals to